Hello, everybody, and welcome back to another episode of Maths. Hope you're all having a wonderful day today. And today we are going to be continuing on this fraction multiplication train with a brand new perspective for multiplication. I think this is a really interesting one, and I don't think it's a perspective.
What are you doing?
I'm making a Maths video.
What's Maths?
Maths? Well, that's my math YouTube channel.
You make math videos?
Yeah, I do.
Whoa, you're such a good math teacher. I'm going to subscribe to Maths right away.
Awesome, thank you. So sorry about that. Just fans, I guess. Anyways, this perspective that we're going to be talking about is maybe something that you haven't seen before. I would guess probably not, but it's going to be super important in motivating things that we do with fraction multiplication. It's going to help you see the bigger picture with it, and it's going to be really useful down the line when we talk about fraction division. And so, with all this in mind, this is going to give you a nice kind of visual idea to think about not just fraction multiplication, but what fractions actually are. Before you get into this though, I would strongly recommend checking out the first part of the Fundamentals of Algebra series. In that series, what we talk about is we kind of give another visual perspective on a lot of the things that we know from arithmetic, and we're going to be making use of some of those today. Those visual perspectives will come in time and time again, and they'll help give a bigger picture for a lot of the more complicated things that we do in math. So even though it's quote-unquote easier videos, they're well worth your time to watch, in my opinion. So assuming that you've kind of taken a look at some of those videos, let's now go ahead and talk about what is this perspective that I've been hyping up here. So let's recall that fractions are division in disguise. So if I had something like a quarter, right? So a quarter, we saw it was the same thing as 1 divided by 4. So we thought of this both as a number, right? A quarter was the same thing as 0.25. We could plot it on the number line, right? If this is 0, this is 1, maybe a quarter is somewhere right here. So we could think of it as a number, but we also noticed that we could think of a quarter as kind of a process or a transformation. And the way we did that is what we did is we took another number line, and we compressed it, right? We divided that number line by 4. So that's compressing everything, right? Keeping 0 fixed, we compress the number line. But in doing so, 1 lines up with a quarter, right? So essentially 1, it gets transformed by dividing by 4. And what we found is that 1 kind of corresponded with a quarter when we transformed it. So we had two ways to think about fractions. We could either think of them as a number or as this process. For more information on that, please go check out my video where I talk about this in depth. So if we think about these as kind of a transformation, what I want to do now is let's consider fraction multiplication with that kind of in mind. So let's say I had something like 3 times 3 quarters. Okay, so we learned how to do this, right? All we have to do is we say, okay, this is the same thing as 3 over 1 times 3 quarters. Then we multiply the numerators and the denominators, right? And I give you a visualization for how we could visualize this, right? So if we take one piece and shade in 3 of them, so that's our 3 quarters. And then for the 3, we would take 3 distinct pieces. And then what we do is we kind of join everything together, right? So, and then we just kind of shade in all of the common pieces, right? And so what we see, we get 9 pieces shaded, and these pieces are each a size of a quarter, right? So we get 9 quarters. It's the same thing, right? So that was one perspective we had on multiplication. But what I want to do now is I want to try and use this perspective here. So what I'm going to do is 3 times 3 quarters. Well, ultimately what's going on is we're doing 3, we're multiplying it by the 3, and then we get 9 from doing that, right? And then we have this over 4. So essentially what we're doing is we are multiplying by 3, but if you recall from the transformation videos in the first part of the Fundamentals of Algebra series, that's the same thing as stretching by a factor of 3, right? So we're taking our number line, we're stretching it by a factor of 3. And then the over 4 part, so multiplying the 3 by 3, we get 9. And then dividing by 4, that gives us 9 quarters. But dividing by 4, that's compressing by a factor of 4. Okay, so then what this means is that 9 quarters is where 3 lands when we've stretched the number line by 3 and compressed it by 4. So let's see this in action. So I'm going to draw on another number line here. And as we know, to stretch the number line, we fix 0, and we're going to stretch everything by 3. So we're multiplying the number line by 3. And what that's going to do is it's going to take the distance between these ticks and triple it. Right, so everything's spread out. So now we see, okay, 1 lines up with 3 since 1 times 3 equals 3. 2 lines up with 6 since 2 times 3 equals 6. And then what we're going to do is we're going to take this number line here and we're going to divide by 4. So we're compressing now. So now all of these are going to be 4 times smaller. And we could fill in more, but we're interested in tracking what happens with the 3, right? Since we're doing 3 times 3/4. So if we look at the 3 here, so this 3, where does that look like it lines up with? Somewhere between 2 and 3. And if we convert 9/4 into a decimal, we're going to get 2.25. So it makes sense that, yeah, it would line up around there. And again, this comes from us stretching the number line by 3, right? So 3 goes over here, but then compressing it back down by 4. So what we can think of fraction multiplication is actually we're doing 2 different things. It's a stretching and then a compression operation. We could have also done it in the other order where we compressed it first and then stretched it by a factor of 3. It doesn't matter the order we do this. You can try that out for yourself though. All right, so let's try another example of this. All right, so let's try 5 times 3/2. Okay, so we know that that's the same as 5 over 1 times 3 over 2, which is 15 over 2, which if we convert that into a decimal is 7.5. Okay, so we can think about this as just regular fraction multiplication as I just did there. So now let's try and draw a number line and visualize the double action that this 3/2 has. It should have the action of both stretching by 3 and then compressing by 2, and wherever that 5 ends up should be this 7.5 or that 15/2. Since we're only dealing with positives here, I'll just draw my number line from 0 going outwards. All right, so since we're multiplying by 3/2, what's the double action? Well, the first part of the action is the multiplying by 3, right? That's the numerator. Okay, so doing so, what do we get? Well, that means we're stretching everything out to be 3 times as large. So 0 is fixed, but then 1 lines up with 3, right? Because the distance between 0 and 1 now has tripled. 2 lines up with 6, 3 lines up with 9, 4 lines up with 12, 5 lines up with 15, 6 lines up with 18, and 7 lines up with 21, right? Everything is going to line up with itself times 3 when we do this stretching, right? And then what we're doing is we're compressing, we're dividing by 2. So now we're making all of these distances here to be 2 times smaller. Once again, 0 is fixed. Okay, so 1 is going to be around there, 2 is going to be here, 3 is going to be around there, 4. Right, so I just took this number line here and I smushed it down, right? That's dividing it by 2. So we see, okay, 2 lines up with 1, the 2 divided by 2 is 1, right? So this all looks good. And now we're tracking what happened to the 5. So we start with the 5 here, and then let's see where we land on the original number line. Looks like smack dab in between 7 and 8, or the 7.5 that we had, right? So we see that this is consistent with what we were looking at in terms of just how multiplication and division stretch and compress the number line, but now we're viewing that as basically both of these happening at once when we multiply it by the fraction of 3/2. So I hope you're starting to kind of see the connection here. We could also do something like, let's try 7 times 3/2, okay? So let's see where 7 is. 7 is right there. So we kind of trace back through the stretching and the compression that we did, and we get between 10 and 11. Let's see if that tracks or not. 7 times 3/2, so 7 times my numerator is 21 over 2. 21 over 2 is 10.5. Yeah, so we're exactly in between there. So we see that doing both of these actions is the same thing as just multiplying by that fraction. Okay, so let's consider something like 3/4 times 2/5. So if I didn't have a fraction here, I'd know, okay, I'm taking the number, I'm stretching it by 2, and I'm compressing it by 5. But actually, that's exactly what we're going to do anyways. So 3/4, that's the number we can put on the number line, right? So if I have 0, maybe I'll do 1/4. All right, so you can check that all those fractions look good. So what we're going to do is we're going to, first of all, multiplying by 2, we're going to stretch this number line to be 2 times big, right? We're going to make all these distances twice as long. So that means the distance between 0 and 1/4 now becomes doubled. Right, so everything just gets stretched. And then what we're doing is we're compressing, we're dividing by 5. That means all these distances become a fifth smaller, right? So I'm going to basically take this region and I'm going to split it up into 5 pieces. All right, so now this will be a quarter, a half, 3/4, and we can keep on going here. But we've already gotten to what we care about because we have 3/4, right? So now it's a matter of, okay, where does 3/4 land? So if I do 3 times 2, that's 6. 4 times 5 is 20. We have 6/20, which is the same thing as 3/10. And we know that that is 0.3. Now, a quarter, that is 0.25. So 0.3, where we land, is slightly bigger than that. Yeah, so it tracks that we graphed this correctly. And again, all we did is the same process. Even though we have a fraction here, we just treated that like a number. We multiplied it by 2, right? The stretching by 2, and divided by 5. There's our 2 transformations with our 1 multiplication. So I think at this point, you should have a good idea of these 2 operations that 1 fraction multiplication accomplishes. But I'm actually going to go even further now and introduce a new perspective that's similar to this, but it is slightly different. So pay attention to that. And to do so, let's go back to the idea of one of our videos in the Fundamentals of Algebra series, which was Let's Be Negative. And the idea in this is we looked at different ways that we could consider negative numbers. One way was that we could consider -5 would be 0 minus 5, where we got negatives by shifting the number line to the left because subtraction was shifting. But we also saw that negative numbers could be accomplished by doing basically -1 times 5, right? We're essentially taking 5 and then we're flipping it, right? Or we're multiplying it by this -1. What I want you to do is recall this method in particular. We know that -5 can be written as -1 times 5. And so in a sense, we actually kind of had an idea in which these numbers right here could be thought of as a transformation to 5, right? This was a transformation of 5 by flipping it to this negative point. Similarly to how we think of fractions as maybe a transformation where we start with 3 and then we divide by 4, right, to get us to the number that this fraction represents. So now what I want to do is let's consider this for any number. Let's consider, for example, 5. 5 is 1 times 5, right? We know that this is true. But why this is important is we can think of this number as essentially being a transformation to 1, namely by stretching it by a factor of 5. So if I take this number line here and I stretch it out by a factor of 5, 1 lands at 5, right? So we can think of 5 as being where 1 lands when we stretch it out by 5. This is the same idea as before. But what I want to do is I want to think of basically 5, instead of being a number, I want to think of it as essentially the transformation that we're applying to 1. All right, so let's try another example to kind of sell this home. What if I did 3? 3 is 1 times 3. So instead of thinking of 3 as a number, I want to think of it as almost this multiplication I'm applying to 1, this stretching that I'm applying to 1 specifically. So if I stretch out this number line up here by 3, 1 is going to land at 3. So this 3 up here, that's the result of 1 that I get from stretching this number line by 3. So it's a really subtle idea, but essentially instead of thinking of these numbers as numbers, kind of like with fractions or with negative numbers, we want to think of 3 and we want to think of 5 as essentially kind of this transformation that we're applying to 1. It's wherever 1 lands when we stretch the number line out by 5, or it's where 1 lands when we stretch the number line out to be 3 times as long. So I hope that idea makes sense, because now what I'm going to do is I'm going to say, what if we consider 3/4? Okay, well, we can think of 3/4 in the same way as 1 times 3/4. But this is where it gets interesting, because remember, multiplying by a fraction is a double action, right? We essentially are going to stretch our number line by 3 and compress it by 4. Okay, so we'll start by stretching it by 3, and then we will compress it by 4. And again, we just care about what happens to 1. And 1, that lands right about there, which is where 3/4 or 0.75 is going to be. So again, it's a really subtle idea, but we're seeing 3/4 as being basically the actual transformation where we stretch the number line out by 3 and then we divide by 4, and then it's just wherever 1 lands, and where 1 lands is also the 3/4. So we both get the number idea of 3/4, but then we also think of 3/4 as purely a transformation. But unlike 5, where 5 was just a single transformation, right, just a stretching, what we're doing now is we're thinking of 3/4 as being a double action, right? It's a stretching by 3 and a division by 4. So it's a really similar idea to what we just did. It has a slightly different nuance to it. But the reason I'm doing this all is because what if I take 3/4 and I multiply it by, let's say, 2/5? Okay, so one perspective I can take on this is that was the one we just did, right? We have 3/4, that's a spot on the number line. We stretch it by 2, divide by 5, and we get to our answer. But another thing we can do, and this I think ties in more nicely with what fraction multiplication is doing. We know fraction multiplication is multiplying the numerators and then multiplying the denominators, right? But if we think of both of these as being actions, we know 3/4 corresponds to the action of stretch by 3 and then compress by 4. And this 2/5 here, that corresponds to the action of stretch by 2 and compress by 5. And what are we doing over here when we actually multiply the fraction? 3 times 2, that is basically us combining our stretches, right? And it's all happening in the numerator. The numerator, as we know, tells us how much to stretch the number line by, right? When we're thinking of 3/4 as a transformation to the number line, the numerator of 3 told us to stretch the number line by 3. The denominator of 4 told us to compress the number line by 4. And so over here, we get this 4 times 5, which is 20 in the denominator. But what that's doing is it's saying it's taking the compression by 4 from over here and combining with the compression by 5 from the 2/5. And it's keeping it all inside the denominator because that is where compression occurs, right? So we see that this gives us another way to think about fraction multiplication. So I hope these ideas made sense to you. You might be still kind of wondering, okay, well, what's really the point in doing all of these different perspectives on fraction multiplication? I can see what he's doing. It's maybe some nice visuals, but how is this going to help me? The point of me bringing this up isn't so that this is how you're going to do your calculations. Obviously, when you're doing 3/4 times 2/5, you're just going to multiply straight across, right? Numerator times numerator, denominator times denominator. But understanding kind of these ideas, these underlying visuals of what these are, is going to be really helpful for understanding future ideas and really just getting an intuition for what's actually going on here. So you don't have to be fluent in writing fraction multiplication like this, but I think that from this video, I hope you at least take away these alternate perspectives on which we can consider fraction multiplication. But that's going to do it for me today. I hope you found it interesting. I hope you found it useful. And let me know if you've ever thought of fraction multiplication in this way before. And I'm looking forward to expanding our fraction abilities, and I will be using this perspective in the future. But until those videos come out, you have a good one, you stay groovy, and I'll see you then.
F.O.A. Maths.